We are working on 1.3, investigating data. This session is very quick. We only 5 slides. So I'm gonna run over it and then go to section 1.4 soon. Okay. So for investigating the data, we interacting with data by this diagram over here. It represents the cycle of the statistical investigation. So let me see. So as you see, the data cycles is you can start with like ask the question, right? For example, like, oh, what is the average age of the merit student in merit student in this year, something like that. And then I start to consider the data, right? By collecting and maybe a samples, or go to the admission to check with it, and then we analyze it by using graph and using shift center, something like that, right? And after analyze, I'm gonna interpret it and then have the conclusion of it, so after finishing some conclusions, I can keep having like a new question, and then the cycle keep going like that way. Okay, so that is about the cycle with interacting data here. We can now move to the next slide. So still talking about the data cycle. Now we have cycle revolves around the research, as you see here, right? And it can be, they can be broad. For example, what makes a runner faster or slower, right? Let me see. Makes a runner faster or slower, right? The second one is serious. So, for example, do cell phone cause cancer, right? Cause cancer, right? So, so that is the cycle revolves around research topics. Let's see the other stuff. Okay, so we're still talking about the data cycles, and the following order is a useful way to plan the analysis. So first we ask the question, right? Oh, sorry. Let's see. Question. And it is important to ask the question, a good question, okay, good question, and consider the data. We determine what data available to answer the question. So as you see from the first one, we ask a good question, like research that's we can manageable, we can we can do it, not the question that we have no idea to do it, you know what I mean? So so like I say, a good question such as like, oh, what is the average age of merit student in 2023, something like that. So that could be a good question to start doing research, because we are there, we are student, we are at Merit College, so we can do this research. Okay, we don't want to try to make some, you know, some question that impossible to do the research. And for the data, you can determine which data available to answer the question. So it could be like samples from a, a class, right? Or maybe a sample from a student at library, something like that. So so we're gonna consider which one is available for you to do that, right? Okay, so we can move to the last line. All right, is analyze the data and interpret it, right? So analyze the data, we can begin visualizing the data from, you know, the graph, and then after that we interpret your analysis according to the shape, to the graph, right? So this sessions is very quick, and I'm gonna move into the I'm gonna move to 1.4 right away after this. Okay, so now oh, okay, move this down. Oh wait, trying to figure out where it is. Yeah, 1 second. Okay, so this is section 1.4, organizing category data. All right, so so we have two kinds of data. One is numerical data, and another one is categorical data. And how to organizing the category data. So in this session, we're gonna answer the question why organizing is important. And we're gonna have two-way table to organize the data, the category data in this session. Okay, so let's move to the first slide. Okay, so why do we need to organize the data, right? First, if you have raw data, it's the data that you just collected. It can be very messy, right? And it's hard to read and understand, and also it's difficult to see the pattern, right? So that's is the raw data, and if you don't organize, right? So organizing data will help us to see the pattern. And keep in mind that this task is not always easy. Okay. So highlight kind of very messy, hard to read, difficult to see the pattern. All right. So that is this line. Let's move to the next line. So now I'm gonna have two-way tables to organizing the data. Okay. So two-way tables that have a two-way table are very common to organize the data. and we display the result. Display the result from two potentially relate variables, and it shows combinations of various variables. Okay. Now let me show you how can we have two-way tables. Here's the examples. So keep in mind that we are talking about categorical data. Okay. We are talking about data. So which is the data in category, okay, such as like gender, right, such as like hair color, something like that, right? So so example, the following two-way tables show subset of your risk survey in your text. So variables can be gender as categorical, see that, right? Whether or not the yacht always wears a seatbelt. So yes or no, we also categorical data, right? So this table over here, as you see, we have male and female, all right? It's a not always or always, right? So for example, I have two in here stand for two males that not always wears a seatbelt, right? Or three in here stand for three female not always wears a seatbelt, right? Or number three here stand for three males that say they always seatbelt when they drive, that's right. So and so on for the lab. So this table tell us right, three male who always wear seatbelt, and there's 10 females in the sample, something like that, right? And 5 people who do not always wear seatbelt. Why 5? As you see, if I adding the female and male here, 2 plus 3 is equal to 5, right? So 5 people who do not always wear a seatbelt. Okay, and then 10 is 10 in the other side. 10 female totally I have, something like that. All right. So that is two-way tables examples. And now I'm gonna move to incomplete data. All right. So this is a question. Even when data looks complete, crucial information may be still missing. For example, highlight it. Question. So even when data look complete, but maybe still missing. So, for example, given data in the following tables here, which sport list is the most dangerous? Right. Well, I would say right now maybe we would think maybe basketball, because we have like 501,251 injuries, but it has choose, right? We also have someone like footballs, like 451,961. injuries, right? You know, we need to have more information for that statement for answer this question. But you know, let's take a look at the next line and see what we have. Okay, so here we go. So incomplete data examples. We keep working on that. And like I stated before, like I answered before, we did think, or maybe that was basketball, right? However, this is not correct. Okay, so these are the color. Not correct, right? We missing critical information. Other information needed, such as like total number of players, right? Because you know, for the basketball could be like a lot of more than 500,000 things, and if you divide 500,000 with, like, for example, like 100,000 or million thousand, or millions players, so then the percent of getting injured could be really different, right? And for example, for the football, I would say football is a one that easily you know, or gonna say dangerous, very dangerous, right? If you having a totals, you can using the number of injured divided by totals. So say number of injured divided by totals, and then you multiply by 100% to get the percent of injured, right? So then you can see which one is more dangerous in percent, right? So which one is more injuries in percent, so then you can compare better, because in here it's just telling us about how many players getting injured, but not talking about how many totals, right? So that is missing, right? Let me use other color actually. And then how common injuries among all the players. So that's also information that we're missing. All right. So let's move to the next slide. Oops. Here. So when you comparing groups, so so this is comparing data. So when you comparing group, the group need to be similar. Actually, the group needs to be similar. All right. The percentage of the rate are often better for comparisons. Okay, so keep in mind that you usually comparing, you should compare by the percent, which is better for comparisons, instead of like just a number of injuries like we did in the previous examples with incomplete data, right? So for example, in here, I did provide like how many participants or how many players that do the surveys, and I got the basketball have 501,251. So the rate of injuries is is 0.0205, which if you convert in they convert in per thousand. Well, that's why if you want to make it nicer, I myself would maybe using the another column with the information for the for the percent tag. Percent tag is good enough, or even the rate is good enough too. You don't have to make per thousand. Okay, so for the percent text gonna be like 40 for the first one, you multiply it by hundreds, you're gonna have 1.44%, something like that, right? Well, I don't need to, I put the percent on the top line, so I don't need to. And the next one gonna be 2.05, right, for the basketball. Okay, so it look like basketball still more dangerous than baseball. Okay, let's see the other one. So I will look at the football now. So it is have 0.05 as the rate injury, right? So gonna be 5.07 or 08, right, route to 2 decimal place, right? So you can see now if you compare the rate of football and basketball, you can see the football is higher than, right? Is higher than the football is higher higher with a rate higher than the basketball. But even those, the injury is less than, but you can see the participant in football is less than the basketball a lot, right? See that, that is a reason. You can also check with some other one, such as volleyball there. Volleyball have no, how volleyball is not. So look like I like right now I'm having the rate of injury per participant is football gonna be the highest one, and you see that, right? The maximum is 0.05. So so that is a reason why I say the football could be the highest one. Okay. So so now for gender and handedness of student in class recorded in the table below. For the question, say, what percent of the class is left hand, right? What percent of the class is left hand? So so you will look at the tables and try to figure out, hey, how many like the number of left-handed people, right? And divide by total, okay, and then multiplied by 100%. So that means what? That means gonna be 15 over 90 times 100%, right? With, if you use a calculators, it's gonna be 16.7%. If you route to 1 decimal place, right? Okay. So so that is the way we find. Keep in mind that this is the question talking about percent, right? If they ask, hey, what's the percent, then you do multiply by percent. If they don't ask for the percent, if they ask for proportion, then you don't have to multiply with 100%. So for example, if they do by proportion, then you don't multiply by 100%. We're gonna do like 15 out of 90 only. Okay, and that's gonna be 0.6167, something like that. All right. So so that is for finding a percent of the class is left-handed. So let's move to the next slide and see the other question. Say that what percent of males are left-handed? So so you have to look at the males that also have left hand first. So number of male left hand. Okay, but now you have to divide by totals. Remember that's they say okay, the percent of the male. See this, right? It's not say the percent similar with the look at the question before. They say the percent of the class. We mean everyone, right? Of everyone. So now the percent of the male, right? We mean right now the totals are the males people. Okay, total of male. Okay, so number of males totally divided by number of the male student, right? Something like that. So and then you multiply 100%. So then you have number of males are left-handed. So you look at the male over here. How many people? How many male that left hand? 10. Okay, so put 10 on the top, and then divide by number of males. Number of males. So how many males do I have? You have to add in to this, and you got 50, right? So total male, right, gonna be 50. So you will have 50 here, and then don't forget to multiply by 100%, and then get to 20%, right? And again, this question about talking about a percent, it is proportion. You don't multiply by 100%. Okay. And that's it for section 1.4. And I'm gonna stop my video here, and we'll see you in 1.5 later.